Namaskar. Welcome to this session. We are going to discuss on systems, its definitions, classification, and examples. I'm Dr. V. N. Sastri. A system is defined as a boundary which separates entities inside it from the surrounding environment and which undergoes changes. Example: constitutional system. The constitutional laws create the boundary which is applicable to all entities within the nation, separating from the rest of the world. Amendments make the boundary conditions change as per the need, time, and context. A system is a collection of logical or physical entities with principles which, in an orderly manner, get connected to fulfill specific purpose or tasks. Examples: educational system, where the entities such as Ministry of Education, Knowledge Commission, Higher Education Councils, universities, institutions, school boards, teachers, students, etc., are the ingredients or the components. Financial system, where the entities are Ministry of Finance, regulators like Reserve Bank of India, NABARD, SEBI, IRDA, etc., banks, financial institutions as insurance companies, NBFCs, National Stock Exchange, Bombay Stock Exchange, mutual fund organizations, pension fund organizations, fintechs, investors, borrowers, etc. A system is a set of entities such as people, machines, process, etc., that interact with one another in an orderly way in order to accomplish some purpose or logical goal. Example: manufacturing system. A product, for example, a car manufacturing company, has various entities such as people, components, assembly lines, testing equipment, etc., which work in sync like a supply chain to produce finished goods or products. Mobile payment system has various entities such as the person who is initiating the transaction as payer, one who receives the pay or beneficiary, mobile phone, mobile application, mobile network, banks, payment gateway, payment service provider, settlement organizations, etc., for enabling the mobile payments in real time. A system is an entity that processes its inputs to deliver outputs and which undergoes change in its state with the progress of time. A transport system, for example, it could be rail, road, air, and water based various travel modes, which basically use the carriers as trains, vehicles, airplanes, and ships to transport goods and passengers from different sources to the respective destinations through the paths in the transport networks. Classification of systems. There are various ways in which systems are classified. For example, it could be a simple and complex system, centralized, hierarchical, and distributed systems, living and non living systems, natural and man made or artificial systems. Based on the size, it could be microscopic or macroscopic system. Based on the number of inputs and outputs, it can be single input, single output, single input, multi output, multi input, single output, or multi input, multi output systems. Based on the time and position, it could be static or mobile, or it could be a dynamic system. Continuous and discrete systems, periodic and non-periodic systems, deterministic and non-deterministic systems, open and closed systems, open loop and closed loop systems, smooth and rough systems, stable, unstable, and robust systems, control systems, which could be manual or automated. It can be feedback and feed forward or combination of both. A simple system is an elementary and identifiable system which cannot be subdivided or decomposed further. A complex system, on the other hand, consists of several simple systems or components Based upon the pattern of integration and the subsystems that are connected together, it can be called as a serial, parallel, or hybrid type of complex system. In this diagram, you see the bulbs are connected through the wire, and even if one of the components or subsystems is not working, the others also cannot work in the serial system. On the other hand, in parallel systems, even if one of the components is not working, the others will continue to work. Whereas in a hybrid system, it can be a combination of serial and parallel systems. Centralized, hierarchical, and distributed systems. In a centralized system, a resource is centrally available at a node for being shared across its other connected nodes or entities. Here, any two entities can communicate. In the diagram, you can see there is a central node, and any two nodes can communicate only through the central node. If you look at the household Wi-Fi routers, which connects various devices or gadgets in the IoT or Internet of Things, then this basically helps to get connected with the external world. So the router basically acts as a central node. In a hierarchical system, a resource is shared through the various levels, nodes, or hierarchical nodes as parent and child. In the distributed systems, it's a combination of centralized and distributed hierarchical nodes. This diagram basically shows how centralized, decentralized, and distributed things are there. Decentralized is also one of the strategies of management where you have the strategic nodes or strategic entities on the top, then you have the tactical decisions or decision making management system, then the operational management system at the bottom. Living and non living systems, as you can see, the plants, animals, creatures, all these are living beings. On the other hand, the non living systems we have also. The natural and man made systems, the heart, the lungs are all natural systems, whereas the signals that we get from for our mobile phones or gadgets in the 5G or 6G systems are all artificial systems. It can be microscopic or microscopic systems. In the microscopic systems, they are too small, like a cell or virus or atom are examples of such small cells. A macroscopic system, on the other hand, is a very large scale system, like the solar system or constellations in the sky are examples of such large scale systems. Static and dynamic systems, like a house is a static system, bookshelves are examples of static systems. On the other hand, the human brain or the flying birds, etc., are the dynamic systems. Periodic and non periodic systems, if the same position is repeated after some time, then it's called as periodic systems. Examples like the rotation of fan or pendulums, etc., but they are so synchronized with respect to time. This the right hand side bottom diagram is a non-periodic systems. Then we have continuous and discrete time systems. In a continuous time system, inputs and output flows or state changes occur continuously over a period of time. These flows or changes may be uniform or non-uniform. So if you have a continuous system, you have the xt as the input signal, which varies with respect to time, and one gets the output as yt. For example, the flowing of water through the taps. In a discrete time system, input and output flows or state changes occur only at distinct time instances or only at separate intervals of time. These flows or changes may be uniform or non-uniform across equal or unequal subintervals of time. So in the diagram, the discrete time systems, here the inputs are not continuous, but they come at different time instances, and similarly you get the outputs. So people walking in a queue or in big airports or shopping malls or in railway stations, in bus stations, etc., where so many people enter together at different times and they get serviced at different times. So this is the example of discrete time systems. Input output systems, uh, single input, single output. For example, the cold milk, when you heat in an oven, we get the hot milk. Single input multi output systems. So water gets converted through the machine or through the heating system, and we get either boiling water or steam, and accordingly the other machines which will give ice. Multi input single output systems. Here say two ingredients, milk and sugar, or milk, sugar and coffee powder, which when boiled together gives the coffee. Multi input multi output system. Example is when milk and sugar is boiled, we may get hot milk, and prepared in various ways, we get koa, peda, rabdi, etc. These are all milk products. Input output communication systems, which are mostly used nowadays in 5G, 6G, and many other domains. So there is transmitter, there is receiver, and depending on the number of antennas, accordingly we get all these four types of systems. Deterministic and uncertain systems. A deterministic system is one where the knowledge of the present input and present state of a system, if we are able to predict what will be the future state or future outcome can be in an exact manner, then it is called as a deterministic system. For example, if you go to an ATM and put your card pin and the amount, then you will get exactly the amount that you want. Similarly, in a printer, whatever you give the inputs, that exactly comes out as the print. Most of the systems represented by mathematical equations are deterministic systems. Non-deterministic or uncertain systems. If by knowing the present state and the present inputs given to a system, if the future state or future outcomes cannot be predicted in an exact manner or exactly, then it is called as a non-deterministic or uncertain system. For example, tossing of a coin or tossing of a dice or picking a card from a pack of cards, etc. These are random events where the outcomes are difficult to predict until the event has actually occurred, even though the number of outcomes may be few or countable. Reality that we see around looks to be uncertain because the outcomes may not be exactly possible to get predicted except in a controlled or lab environment. Closed system and open systems. In a closed system, all changes are prompted by endogenous or internal activities. For example, the solar system, if we consider, where mass and energy transformations are preserved due to the gravitation, rotation, and internal activities. In an open system, change in states happen due to both exogenous and endogenous activities. That means internal and external activities. Example, room door gets opened when a person gets into the room or comes out of the room. Intelligent open loop and closed loop systems. So there is a process where one gets the inputs, the process gets the inputs and it gets the output. But there is a controller to regulate, for example, your light switch, on off switch. So if you put the on, the light becomes on, the light glows, the bulb becomes on and the light glows. This is an open loop system. and it continues until you again put it off. On the other hand, the closed system is one where the output is sensed and measured, and it's given back to the controller, which controls and gives the output. For example, you have a regulator. By looking at the room conditions, one can change the speed of the fan, or even an AC in the rooms. Depending on the conditions, one can sense what is the final temperature that is required, and accordingly the controller automatically or in a manual way gets sets to the desired requirements or outputs. Control systems, it can be manual and automated control systems. So there is a process, there is a controller, the inputs received and processed gives the output, there is a feedback measured, looking at what the outcome is, as the same example of regulator for a fan. There can be a automated control system also. So control system has components as controller consisting of the control algorithm and sensors, which basically sense what is the output or the state of the system, and this feedback is given to the controller. Based on the error signal, the actuator works to give the required input for getting the desired outputs. So this is what is called as a control system. So one of the challenging engineering problems is how do you make an inverted pendulum get balanced. Okay, so the pendulum is inverted, so it has to get balanced in the vertical position. So on a moving cart, when the pressure is or force is applied either on left or right side, accordingly it gets balanced. But keeping the vertical pendulum remaining in a balanced position is the real challenge. So that's what the challenge for a control system is in a lab environment. Similarly, if something is to be balanced, a pendulum, how you will move so that it remains balanced. In an automated factory, if you see, there is a motor, there is a sensor, and when the item is to be picked and dropped, accordingly it can get the feedback and then control to see that the entire process is automated. This is how the control systems work. In our body also we have various controls, which basically temperature control, pressure control, sensory controls, etc. Smooth and synchronized interrupt systems. So these are examples. So in a orderly way, one can actually make the synchronization to happen, mainly the unmanned aerial vehicles, or you have the road transport systems where it is fully automated, then they remain synchronized and move in an orderly way. It could be a rough system also, where the disturbances, slight disturbances, can cause change in the state. Stable, unstable, and robust systems. So a chair on the left hand side is a stable chair, but the chair with the wheels, if somebody sits in an awkward or wrongful way, then it becomes unstable. Similarly, you see the person balancing and going to the top of through the stairs, and one person trying to put like a circus. Even this bird, which is trying to naturally balance itself to see that it is able to do that. These are examples of stable, unstable, and robust systems. Feedback control systems. So there is a process or a plant to which inputs are given, and there is also a disturbance for any process or plant, but it gives the outputs. So, but there is also a sensor which senses and measures the outputs and gives this to the controller, which controls the input to get the desired output. So this is how the control system works, through the feedback gained from the received from the outputs of the process. Feed forward control system is one where the process gets the input and gives the output. But here the disturbances are measured or sensed and given that information to the controller, and the inputs received the controller along with the disturbance inputs. Then it controls finally the inputs and the desired outputs are obtained. This is an example of a feed-forward control systems. While driving, we see somebody ahead and then apply the brakes. Okay, or once you put your vehicle going towards backward, reverse gear, then there are mirror also the signals received through the camera will give you the position where to take turns or come out, etc. So there is this combination of feedback and feed forward control systems. So there is also something called as your embedded systems when they are put in the device itself. Feedback, feed forward control systems, and these are the process. What you see on the right has feedback controller as well as feed forward controller, which basically look at the output as well as the measured disturbance and then process the inputs to get the desired outputs. So in risk management systems or antivirus systems, these are mostly used by looking at what the signatures are and accordingly how they can be filtered to stop any type of attacks on the systems. Other types of systems, autonomous system, independently administered or centrally managed. Autonomic system, which is more of self-configuring, self-optimizing, self-healing, and self-protecting. Information systems, where computing, communication, sensing, coordination, and storage takes place in a network environment. Software and hardware systems, security systems or secure systems, where the goals are basically to achieve confidentiality, integrity, availability, authentication, authorization, non-repudiation, accountability, access control, trust, and reliability. Private and public systems, ownership, control, and management by individuals or groups or business entities in a private manner. On the other hand, public systems are governed by the government or its entities. Biased and unbiased systems, which are favored or there is no equal opportunity given, then they are biased. Otherwise, they are unbiased, where transparency and auditability is one of the important factors. So, in summary, there are various definitions and perceptions of a system. Inputs, outputs, boundary, process, and states are fundamental aspects of a system. Systems are classified into various types. One can observe nature and understand about systems through its various examples that it provides. Human being is a convergent or convergence of multiple types of systems where you can see all that in our body itself. Universe is a complex system created and managed by Bhagwan. What this Bhagwan means? The abbreviations of Bha means Bhumi, Ga means Gagan, Va means Vayu, A means Agni, and Na means Neer, which mean Bhumi means earth or mass, Gagan means sky, Vayu means air, Agni means fire, Neer means water. These are the Pancha Bhutatmas. So they basically generate the various signals of touch, sound, smell, light, and taste, respectively, and they are sensed through our sensory organs. For example, skin, ear, nose, eye, and tongue in the respective way. So this is how the system works, and this is what we call as Bhagwan. Thank you very much.